What are some concrete use cases for metaclasses? I have a friend who likes to use metaclasses and regularly offers them as a solution. I am of the mind that you almost never need to use metaclasses. Why? Because I figure if you are doing something like that to a class, you should probably be doing it to an object. And a small redesign/refactor is in order. Being able to use metaclasses has caused a lot of people in a lot of places to use classes as some kind of second-rate object, which just seems disastrous to me. Is programming to be replaced by metaprogramming? The addition of class decorators has unfortunately made it even more acceptable. So please, I am desperate to know your valid, concrete, use cases for metaclasses in Python. Or to be enlightened as to why mutating classes is better than mutating objects, sometimes. I will start. Sometimes when using a third-party library it is useful to be able to mutate the class in a certain way. This is the only case I can think of, and it's not concrete.
The purpose of metaclasses isn't to replace the class/object distinction with metaclass/class, it's to change the behavior of class definitions, and thus their instances, in some way. Effectively, it's to alter the behavior of the class statement in ways that may be more useful for your particular domain than the default. The things I have used them for are tracking subclasses, usually to register handlers. This is handy when using a plugin-style setup, where you wish to register a handler for a particular thing simply by subclassing and setting up a few class attributes. E.g., suppose you write a handler for various music formats, where each class implements appropriate methods, play/get tags, etc., for its type. Adding a handler for a new type becomes the metaclass then maintains a dictionary of .mp3 column mp3 file, etc., and constructs an object of the appropriate type when you request a handler through a factory function. Changing behavior. You may want to attach a special meaning to certain attributes, resulting in altered behavior when they are present. For example, you may want to look for methods with the name _get_foo and _set_foo and transparently convert them to properties. As a real-world example, here's a recipe I wrote to give more C-like struct definitions. The metaclass is used to convert the declared items into a struct format string, handling inheritance, etc., and produce a class capable of dealing with it. For other real-world examples, take a look at various ORMs, like SQL Alchemy's ORM or SQLobject. Again, the purpose is to interpret definitions, here SQL column definitions, with a particular meaning.
Let's start with Tim Peters' classic quote. Metaclasses are deeper magic than 99% of users should ever worry about. If you wonder whether you need them, you don't. The people who actually need them know with certainty that they need them and don't need an explanation about why. Tim Peters, CLP post December 22, 2002. Having said that, I have periodically run across true uses of metaclasses. The one that comes to mind is in Django, where all of your models inherit from models.model. Models.model, in turn, does some serious magic to wrap your DB models with Django's ORM goodness. That magic happens by way of metaclasses. It creates all manner of exception classes, manager classes, etc., etc. See Django/db/models/base.py class model base for the beginning of the story.
I have a class that handles non-interactive plotting as a front-end to Matplotlib. However, on occasion one wants to do interactive plotting. With only a couple functions, I found that I was able to increment the figure count, code row manually, etc., but I needed to do this before and after every plotting call. So to create both an interactive plotting wrapper and an off-screen plotting wrapper, I found it was more efficient to do this via metaclasses, wrapping the appropriate methods, than to do something like this method doesn't keep up with API changes and so on, but one that iterates over the class attributes in __init__ before resetting the class attributes is more efficient and keeps things up to date. Of course, there might be better ways to do this, but I found this to be effective. Of course, this could also be done in __new__ or __init__, but this was the solution I found the most straightforward.
The only legitimate use case of a metaclass is to keep other nosy developers from touching your code. Once a nosy developer masters metaclasses and starts poking around with yours, throw in another level or two to keep them out. If that doesn't work, start using type.__new__ or perhaps some scheme using a recursive metaclass. Written tongue-in-cheek, but I've seen this kind of obfuscation done. Django is a perfect example.
If you want to support the channel, please consider liking and subscribing.